Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 26, Episode 118, for broadcast on the 2nd of October 2023. Coming up on SpaceTime, does antimatter fall up or down? NASA's Osiris-Rex mission returns home, and Iran's nuclear missile program advances another step. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Does antimatter fall up or down under the influence of gravity? It's an age-old question among first-year physics students the world over. And now we finally have an answer. Yes, it falls down just like regular matter. And after all, why wouldn't it? Einstein's theory of general relativity says antimatter should behave exactly the same as normal matter. After all, the forces acting on an antimatter particle by the effect of mass on space-time don't change just because the particle now has an opposite charge. But somehow, humans find it comforting to finally confirm the answer by way of a unique experiment using a cloud of antihydrogen atoms. Scientists observed the antihydrogen mostly took a downward path, just like regular hydrogen would. But although the answer seems simple, the experiment itself wasn't easy. According to the standard model of particle physics, the foundation stone upon which science's current understanding of the universe is based, equal amounts of matter and antimatter were produced when the universe burst into existence 13.8 billion years ago in an event these days referred to as the Big Bang. Physics shows us there's almost no difference between matter and antimatter other than their charge. And when matter and antimatter come into contact, they annihilate each other, producing high-intensity gamma radiation. And all this begs the question, if equal amounts of matter and antimatter were produced in the Big Bang, why didn't the universe annihilate itself in a sudden flash of purple light as soon as it came into being? And why do we live in a universe filled with matter rather than antimatter? In fact, we now have abundant evidence to show us that the observable universe is made up almost exclusively of matter. If there were large pockets of antimatter, it would annihilate as soon as it came into contact with the nearby matter, producing very highly detectable, high-intensity gamma radiation. And this has not been observed. Therefore, figuring out how and why our universe ended up with an abundance of only matter rather than antimatter is one of the biggest open questions in particle physics today. In confirming that antimatter, just like regular matter, is gravitationally attracted, the finding also rules out gravitational propulsion as the reason why antimatter is largely missing from the observable universe. The experiment was carried out by researchers from the International Anti-Hydrogen Laser Physics Apparatus, or ALPHA collaboration, located in Switzerland at CERN, the European Organisation for Nuclear Research, and their findings have now been published in the journal Nature. Understanding the nature of antimatter can not only help scientists understand how the universe came into being, but it can also enable new innovations never before thought possible. And of course, beyond the practical and real, there's the imagined, such as the antimatter-fueled warp drives and photon torpedoes of Star Trek fame. Antimatter is completely real, but it's mysteriously scarce. Alpha Collaboration member Jonathan Wurtell from the University of California, Berkeley, says many indirect measurements indicate that gravity interacts with antimatter just as expected. But until this new experimental result came in, nobody had actually performed a direct observation that could rule out, or for example, that antihydrogen moved upwards as opposed to downwards in a gravitational field. Your body, the Earth, and almost everything else scientists know about the universe are overwhelmingly made up of regular matter, consisting of things like protons, neutrons, and electrons. On the other hand, antimatter is regular matter's twin, though with some opposite properties. For example, antimatter protons, called antiprotons, have a negative charge, while regular protons have a positive charge. And antimatter electrons, called positrons, have a positive charge, while regular electrons have a negative charge. But because they annihilate each other, antimatter is really hard to test, because once you make antimatter, you've got no way of holding on to it. As soon as it touches regular matter, that could be a container, it could be the air, it'll immediately annihilate. Another Alpha Collaboration team member, Joel Fajan, also from the University of California, Berkeley, says that for a given mass, these annihilation events between matter and antimatter are the densest forms of energy release known. So in a very real sense, it would be the ultimate power source. The amount of matter used in the Alpha experiment was small, so small that the amount of energy created by antimatter annihilations could only be perceptible using very sensitive detectors. And so the team needed to manipulate the antimatter very carefully in order not to lose it. Broadly speaking, the Alpha Collaboration produced antimatter and then used it to conduct a Leaning Tower of Pisa type of experiment. Now that term, Leaning Tower of Pisa, refers to the kind of experiment carried out by Galileo back in the 16th century. His experiment was designed to demonstrate the identical gravitational acceleration of two simultaneously dropped objects of similar volume but different mass. NASA Apollo 15 astronaut David Scott repeated the exact same experiment on the surface of the moon.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got
beautiful picture, Dave.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? Which proves that Mr. Galileo was correct in his findings.
For the Alpha experiment, the antihydrogen was contained within a tall cylindrical vacuum chamber with a variable magnetic trap called Alpha G. The scientists reduced the strength of the trap's top and bottom magnetic fields until the antihydrogen atoms could escape and the relatively weak influence of gravity became apparent. As each antihydrogen atom escaped the magnetic trap, it touched the chamber walls either above or below the trap and annihilated, which the scientists could then detect and count. The researchers repeated their experiment more than a dozen times, varying the magnetic field strength on the top and bottom traps in order to rule out any possible errors. They observed that when the weakened magnetic fields were precisely balanced at the top and bottom, about 80% of the antihydrogen atoms annihilated beneath the trap, a result consistent with how a cloud of regular hydrogen would behave under the same conditions. In other words, gravity was causing the antihydrogen to fall down, not up. Despite some modest sources of antimatter, like the positrons emitted from the decay of potassium in bananas, scientists don't see much of it in the universe. However, the fact that the laws of physics predict that antimatter should exist in roughly equal amounts with regular matter remains a massive conundrum, these days referred to as the baryogenesis problem. One potential explanation was that antimatter was gravitationally repelled by regular matter during the Big Bang. The trouble is these new findings suggest that theory no longer seems plausible. Wurtell says that while they've ruled out antimatter being repelled by the gravitational force as opposed to attracted, That doesn't mean there isn't a difference in the gravitational force on antimatter, and only a more precise measurement will tell. So, the Alpha collaboration will continue to probe the nature of antihydrogen. In addition to refining their measurement of the effect of gravity, they're also studying how antihydrogen interacts with electromagnetic radiation through spectroscopy. If antihydrogen were somehow different from regular hydrogen, that would be a revolutionary thing, because the physics laws, both in the quantum mechanics world and gravity, say the behaviour should be the same. But Wirtle points out we won't be sure until we actually do the experiment. And let's face it, that's what science is all about. This is SpaceTime. Still to come, NASA's epic Osiris-Rex mission returns home, and Iran's nuclear missile program advances yet another sinister step. All that and more still to come on SpaceTime. NASA's first ever asteroid sample return mission has arrived safely back on Earth, parachuting down onto a US military test range in the Utah desert. The Osiris-Rex sample return capsule landed right on target following its 7-year, 6.21 billion kilometre return journey to the half-kilometre wide near-Earth asteroid Bennu.
Recovery operations, helicopters 1 and 2 have arrived at the holding location.
So good news, our helicopters are ready to go and begin those recovery operations just as soon as we have confirmation of touchdown here. And as the sun begins to rise in the west coast, the SRC is going to be streaking across the atmosphere above San Francisco, California, about 82 miles in altitude. It's going to be coming in hot, over 5,000 degrees Fahrenheit, almost a couple seconds after it hits that atmosphere. That's about half as warm as the surface of the sun, to give you some context. But don't worry, our sample will be safe and sound. Within, we have a heat shield, which is made of a phenolic impregnated carbon ablator. It's a very fancy term to describe what's going on with this heat shield. It basically ablates away or burns away any kind of heat flux that develops on that outer shell, making sure that our sample is safe and cool within. Similar technology that we use with astronauts coming back from the moon or any kind of other landers that we have going into planets and moons. So we're just a couple moments away from this key moment. It's going to be very exciting next couple 13 minutes here, and you'll hear a couple call-outs come in from just next door in our mission operations team as they begin to get us ready for this key moment. It's a journey of 3.86 billion miles, getting reduced to the scale of mere miles. 82 miles above the surface of the Earth in San Francisco. A couple key events are going to happen as soon as we get into the Earth's atmosphere. Very quickly we're going to deploy our drogue parachute. This is for stability, stabilizes our descent, and make sure that we are continuing to target that landing ellipse that is here in the Utah Test and Training Range. It is a 36.5 by 8 mile landing ellipse that is here, marked out for that recovery operation. This team, I'll remind you, just a few hours ago, gave that command to release the SRC on this long journey. It's been on its own for 4 hours. There's nothing we can do at this point. It's coming in, rain or shine.
EDO milestone. The SRC has entered the Earth's atmosphere. UTTR tracking assets have acquired.
And here we go. Start your stopwatch right now. We are 13 minutes of entry, descent, and landing as it enters into Earth's atmosphere. The punishing deceleration that spacecraft, that SRC, is experiencing right now as it comes in at about 27,650 miles an hour, glowing brightly in the sky. And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 G-forces, punishing G-force on our SRC. At this point, we have entered in over San Francisco, California, and are very quickly going to be approaching the Utah Test and Training Range just a little bit further to the east. Entry was at
EDO milestone. SRC is experiencing maximum heating and maximum deceleration.
So you just heard right there, we're experiencing that 5,000 degree Fahrenheit maximum heating, burning scalding hot on that heat shield that is protecting our sample within, and maximum deceleration that is at 32 G-force, punishing deceleration from Earth's atmosphere, the drag forces that are acting on that SRC. Our next milestone, we'll be expecting that drogue parachute deployment. That'll be at about 102,300 feet altitude. That will stabilize our descent and slow us from hypersonic to subsonic speeds as we continue to target the Utah Test and Training Range.
Expected EDO milestone. SRC commands drogue parachute deploy.
So we heard that command to deploy the drogue parachute. At this time, 8:44 a.m. Mountain Time, the Osiris Apex spacecraft is at its closest approach to Earth. that will be on to its extended mission visiting the asteroid Apophis in the year 2029, continuing this incredible mission at another world. And in just a few moments, we should enter into special use airspace at approximately 8:46 a.m. That's going to be at 10 miles off the deck here at Utah Test and Training Range. That SRC is nearly 3 feet wide, 1.6 feet tall. It's a small object, so quite a challenge to track this as it comes searing into Earth's atmosphere. This area was specifically chosen for this mission. It's a wide open, vast desert space, relatively flat, perfect to land this sample today. Our next milestone, we should be expecting main parachute deployment at around 8:49 a.m. Mountain Time.
CDL milestone, we have confirmed parachute deployment.
Wow, and after an exhilarating streak across Earth's atmosphere, there is that orange creamsicle colored parachute, just a delight, a sweet delight to see in our sky here over the Utah Test and Training Range. Just a few minutes away from getting that sample from the other side of the solar system, from the surface of asteroid Bennu at sample site Nightingale, to the rugged terrain of the Utah Test and Training Range. It looks like winds are relatively low, not a lot of rocking back and forth. Those parachutes seem to be perfectly smooth coming down, that parachute there. Continuing to descend, the slight little bit of tilt back and forth of our SRC as it comes to its resting velocity of 11 miles per hour as it makes that final descent. That parachute deployment was given internally by the spacecraft, and once that successfully lands, the teams will begin the next crucial phase of this mission, the sample recovery operations. They've been rehearsing for this moment for months, literally years really, leading up to this key moment, and are ready to begin those operations to get that SRC into our portable clean room here and extract that sample canister within. The ground really closing in now on that SRC.
CDL milestone, Helo 1 has visual on the SRC below the chute.
That is phenomenal. And once again, just setting the context for this, when we first hit the top of the atmosphere, we were at 27,650 miles per hour. We are now leisurely decelerating under our orange parachute to 11 miles per hour. Incredible amount of deceleration there as Earth's atmosphere really helped us out quite a bit. Getting that initial deceleration, our drogue parachute initially stabilizing our descent, and then ultimately that main parachute bringing us home.
EDL milestone, we have touchdown. I repeat, EDL SRC has touchdown.
And touchdown of the Osiris-Rex sample return capsule. A journey of 1 billion miles to asteroid Bennu and back has come to an end, marking America's first sample return mission of its kind and opening a time capsule to our ancient solar system.
NASA Chief Bill Nelson hailed the mission, saying the samples contained aboard the capsule will give scientists an extraordinary glimpse into the beginnings of the solar system. The mission collected an estimated 250 grams of regolith from the ancient asteroid's rocky, boulder-strewn surface. The Osiris-Rex spacecraft released its re-entry capsule just over a day before touchdown at a distance of over 108,000 kilometres from Earth. The spacecraft itself then flew past the Earth to continue on with its mission. It'll study another asteroid called Apophis. Meanwhile, the re-entry capsule hurtled down towards the Earth's surface at some 45,000 kilometres per hour, using only atmospheric drag to slow down enough for 2 successive parachutes to be deployed, allowing the capsule to float down to a gentle desert landing. The only concern during the re-entry was the deployment of the main parachute far higher than originally anticipated. It deployed at about 20,000 feet or 6,100 metres instead of the 5,000 feet or 1,500 metres originally planned. The now blackened metre-wide tyre-sized capsule touched down gently onto the rocky desert floor, only to be quickly surrounded by waiting scientists taking readings. After confirming the capsule survived its journey and was not breached, meaning its contamination seals were still intact, the crew placed the device in a sling and transported it by helicopter to a specially prepared NASA clean room. Meanwhile, the Osiris-Rex spacecraft is continuing with its mission. After releasing the re-entry capsule, it fired up its engines and continued on to the next part of its journey, a rendezvous with the asteroid Apophis. Like Bennu, Apophis is a near-Earth asteroid. It'll pass within 32,000 kilometres of the Earth in 2029. Now, it was originally listed as a potential Earth impactor, but as more and more data on its orbit came in, it showed that it will miss the planet. Not by much, less than the altitude of many satellites, but it will be a miss. Meanwhile, the samples from the asteroid Bennu have now been flown aboard a C-17 Globemaster transport to the Johnson Space Center in Houston, Texas. That's where they'll be divvied up and studied. About 75% of the samples will be conserved for study by future generations, with the remaining quarter handed out to scientific teams across the United States and even overseas, including Australia, with a team from Curtin University also getting some samples for experimentation. The Curtin team of 6 researchers, who are all members of the Osiris-Rex science team, will use sophisticated instruments to study the samples and gain invaluable insights into the origins of the solar system and life itself. These asteroids are composed of the original materials of the solar system, dating back some 4.6 billion years, and they've remained relatively intact ever since. Bennu surprised scientists in 2020 when the probe, during its brief contact with the asteroid's surface to collect its samples, shockingly sank over a metre into the regolith, revealing an unexpected low density for the asteroid. Instead of solid rock, it's more like a kid's pool filled with plastic balls. Understanding Bennu's composition is important, as this asteroid has a 1 in 2,700 chance of catastrophically slamming into the Earth in 2182. We now know Bennu is a rubble pile asteroid. That means it's entirely made up of fragments ranging in size from massive boulders bigger than cars down to tiny grains of dust. This detritus was all ejected during the destruction of a much larger parent asteroid. Associate Professor Nick Timms from Curtin University's School of Earth and Planetary Sciences says Osiris-Rex will reveal insights into the molecular precursors of the origins of life, and it contains water molecules locked in its minerals. Bennu is a lumpy C-group asteroid, a carbonaceous and volatile-rich group that has been relatively untouched since formed. And so this gives scientists a window to look back to the beginnings of the solar system. These samples are some of the most pristine asteroid rocks available. Unlike meteorites that reach Earth and quickly become contaminated by the planet's atmosphere, surface material, water and biota, the Bennu samples are pristine and unblemished. So with Bennu, scientists will be analysing unspoilt samples from some of the oldest objects in the solar system. Tim says we'll be able to tell huge amounts about what happened when the solar system was nothing more than dust and gas, and the processes that brought planets together and created the ingredients for life on Earth.
One of the benefits of flying a spacecraft to these space objects and asteroids is that we can bring these rocky materials back to Earth without being contaminated by the Earth.
See, that's the problem with meteorites, isn't it? No matter how fresh they are, they've still got earthly contamination on the outside.
Yeah, I mean, meteorites are great. They're space rocks that made their own way to Earth, which is very handy for us. And we can go and collect them from the Earth's surface. But the longer they lie around on the Earth, then they can get Earth contamination by water or Earth's biological organisms and things like that. And so the longer they lie around, the more difficult it is for us to tell what signals are from the space rock and what has come from the Earth contamination. So isolating the returned material from Bennu is a really important thing because we can preserve its integrity in terms of the chemistry of the rock types and the particles and all of the molecules that are out there on the asteroid. We can then see what they're like without worry that it's been contaminated from Earth.
There must be special precautions and procedures that need to be followed.
Yeah, absolutely. There's a very long list of procedures that have been developed by the mission scientists to try and achieve that. One of the main things is being handled and stored in a special ultra-clean laboratory. It's basically what looks like a huge fish tank or glass tank with holes in the sides where there are sort of plastic gloves that people on the outside can reach inside the gloves then and handle the material inside the big tank. And the tank is being purged with nitrogen gas so that Earth's atmosphere doesn't contaminate the sample. And that's a really important step in trying to curate these samples. So some of the sample will be stored away in very well-sealed containers for future scientists to look at when, technology gets better and we can discover more and more things that we can't even fathom right now.
They did that with the moon samples from the Apollo missions too, didn't they?
Absolutely, yes. I mean, they're over 50 years old. Even on the 50th anniversary of the moon landings, they opened some of these samples for the first time, and technology has changed so much in 50 years that a whole array of new techniques can be employed to actually look at different types of analyses and chemistry of the volatile elements and all sorts of things from those moon rocks that they recently opened. So a similar sort of thing will be happening to the Bennu sample too.
Now, we've had samples from asteroids before. Curtin University were given samples from the Hayabusa 2 mission, and also maybe, did you get Hayabusa as well? Were there samples from there? Or?
Yeah, we've been involved at Curtin, involved in every single sample return mission in the modern era, really. We also have got a long track record at looking at the Apollo samples from the moon as well, which is a real privilege position to be in. We've developed expertise along the way. So the first asteroid to be visited by the Japanese space agency JAXA, was from an asteroid called Itokawa, and there were only 1,500, that's 1,500 specks of dust returned from that one. A really small amount of material.
Yeah, and we've been looking at problems during the gathering of it, I believe.
Yeah, it didn't quite go right, but when it arrived back, and they put it in a similar clean laboratory and basically dusted out the inside of the sample canister, and they found 1,500 specks of dust which were from the asteroid that had blown in there. And so we've been privileged enough to look at those and examine those and find quite a lot, even though the tiny specks. Our instruments are so high-tech and highly tuned that we can get lots out of material even that small. And then more recently, Ryugu, another asteroid, was visited by JAXA, and material was returned from that, only 5.4 grams, which is about the same weight as about 3 playing cards from a deck of cards. So it's not very much material in terms of weight, but that has also been absolutely brilliant to see lots of new information being derived and analysed from those materials as well.
Now, the Osiris-Rex mission was very different. It almost got eaten up by the asteroid because the asteroid was so... Is what's the term? Undense.
Yeah,
it almost sank into it.
Yeah, I guess my view of an asteroid when I was much younger as a kid, was these are kind of solid blocks of rock that kind of make their way around the solar system.
Little versions of the moon.
Yeah, that kind of thing. But the more that we look out into space with telescopes and visit these asteroids with spacecraft and bring bits back, we realize that many of them are just piles of rubble. That's like bits of rock and dust, kind of leftover bits and bobs from the early times in the solar system when the planets were first formed. They basically accreted together. That means all of the bits have stuck together, and now they sort of orbit around the sun. And it's amazing that they're still around, to be honest, because they're so fragile and just collections of rubble.
Instead of little rock piles, you've got to think of them as almost like piles of dust.
Yeah, they call it soil, I guess.
Yeah,
regolith, exactly. So, and that's what the Rex part in Osiris-Rex stands for, is Regolith Explorer. It's quite a different type of material than I was envisaging as a kid, but that's the way science goes. Even in my lifetime, our understanding has changed incredibly about our neighbouring object.
You'll be given a portion of this material. That in itself must be a great honour to be selected as part of the scientific team to examine these things. Are there certain criteria that NASA are looking for, or we want someone to examine the chemical composition of any atmosphere inside the asteroid or inside the regolith, or the magnetic field of the regolith, or the origins of the regolith's composition? How does that all work?
Yeah, that's a great question. Yes, that's how the mission scientists have assembled the analysis team. And when I say team, there are about 230 researchers from around the world who are closely involved in this, looking at the samples that have been returned. And everybody has a different role, and everyone is bringing their own expertise and instruments that they use in terms of measuring different aspects of these materials. So there are some of us who are looking at the geochemistry of the minerals in the rocks and the dust to understand more about how they formed and when they formed, to date them. There are some of us who are looking at the arrangement of all of the particles and texture and the microstructure of them, and figure out how processes have happened to make all of these things stick together and what's happened to them since, and if they've been hit by other impacts and all of those sorts of questions. And there are lots of teams, not necessarily at Curtin, but around the world, who are looking at different aspects of this, including the magnetic properties, including the organic molecules that we can find, or we're hoping to find in the sample, and so on and so forth. And together we can answer lots of different questions which were posed right from the outset of the mission to start with.
What are some of those questions?
They include a whole array of things. I mean, there's quite there's a long list that we, the scientists, as it were, are privy to. So I'll just just summarize some of them. I mean, the asteroid is meant to be, we think, a relic from the early solar system that formed probably around about 4.5 billion years ago in a very dynamic and violent part of the solar system history. And like I said, the leftovers of planet formation. So by looking at these particles and fragments, we can maybe get some insights into how planets formed and what happened to the bits that didn't end up being planets. Some of the carbon-rich material that we're hoping to see in the sample will form molecules and compounds which are organics, things like amino acids and things, which ultimately are the precursor building blocks for life as we know it on Earth. So we can hopefully get a glimpse of the variety and the types of organic molecules that are out there to help understand how Earth life might have evolved. We're also hoping to see if the materials can be seen to have water or other resources which can potentially be used in future missions to help us explore space. If we land on these asteroids, can we get water out of the rocks and the material to then sustain life, for hopping to another place, or helping to make fuel for refueling stations, and those sorts of very science fiction sounding things. And the other reason that we want to look at this material is to figure out its physical properties, its strength, density, and so on and so forth, to link through to how we can interpret what we can see through telescopes at other asteroids that we can sense in the solar system. And so if we can ground truth our telescope observations with microscope observations and say, right, this rock has that kind of response in the telescope, and therefore we can see all of these other objects, we can make interpretations of those that were a lot more robust. And also if we understand about things about strength of the material and so on, then we can think about how we can maybe deflect asteroids in the future if any of them end up being dangerous to the Earth by being in an orbit which may one day impact the Earth. We can send spacecraft up there to try and deflect asteroids out of the way to mitigate hazards. It could be disastrous if a large one of these things hit Earth. It could be very destructive indeed.
Bennu is, of course, one of those asteroids, one of those near-Earth asteroids, which do pose a credible threat. 2,700 to 1 chance of hitting the Earth? That's not much, but it's there, and it's less than 200 years away. We'll see how its orbit goes. That's where things like understanding the Yukovsky effect comes into it.
Yes, that's right. So the spacecraft that ultimately delivered the sample back to Earth spent a long time orbiting the asteroid before it landed on it. Well, one, to make measurements of the three-dimensional nature of the asteroid surface to figure out exactly where to land. That was a challenge in itself. These things have boulders bigger than cars and
it
tiny
wasn't very
fragments.
smooth, was it?
No, they're very rough surfaces and quite a challenging thing to find a place for a spacecraft to go and sample without damaging it. But also to look at its orbital properties and how things like the sun illuminating one side of the asteroid changes its orbital properties as it heats that side of the asteroid up and makes the dynamics shift. And like you say, those things were very poorly understood. I think there have been leaps and bounds in our understanding of just by this spacecraft orbiting Bennu for a long time to get a lot more information about how all of that works and those kinds of phenomena. So it's been a really successful mission. It's very quite phenomenal.
One of the big mysteries about planet Earth is understanding where the water came from. We don't really know. Originally, we thought it may have come with the planet when it formed. Then the idea was that probably came with comets. But when you study the water in comets and the water in Earth, the ratios of hydrogen to a hydrogen isotope called deuterium weren't right. But we did find that there are lots of asteroids which had similar hydrogen to deuterium ratios to what we find here on Earth. That'll be one of the things I take it scientists will be looking for with Bennu.
Absolutely, and that's one thing that we can do very well here at Curtin University is we have an instrument called an atom probe, which can basically reconstruct the chemistry, geochemistry, and atomic structure on a nanoscale, and we can look at the surface of the particles that have returned and see how the sun has basically implanted radiation into the sample and caused the sample to change its geochemistry. And that kind of process we found out from looking at samples from asteroid Itokawa has been instrumental in implanting things like hydrogen into the surface of these asteroid particles, which then, if you think, then they get delivered to Earth and can form naturally as meteorites, which build up over a long period of time. is a very viable mechanism of getting hydrogen, smuggling hydrogen from the sun to Earth. So it's interesting to think that maybe some of our water on Earth actually originated from the sun.
What else would you guys be looking for? Do you guys have a set list of targets you're aiming at?
Well, we have a vast array of instruments which are very tuned to look at the kinds of problems that we might want to understand. We don't quite know what we're going to get yet. We're still at very early stages of unwrapping the capsule and seeing what samples there. So we're kind of ready for a whole range of things depending on what we get. But one thing that we've got great expertise in at Curtin is dating rocks. We've been kind of in the business of dating rocks for a long time and measuring the radioisotopes and for radioactive decay, figuring out how old a particular mineral is, and then linking that back to how it formed and when it formed and what's happened to it since. And so we'll be looking forward to dating some bits of Bennu and figuring out what happened to them, when they formed, and what happened to them since. It's something that we do very well.
How do you do that? Is that looking at zircons or?
Yeah, zircon is a mineral that naturally contains a radioactive clock, uranium that decays to lead. And that's found not in abundance, but quite commonly in rocks from Earth. The type of rock that we're expecting to get from Bennu isn't perhaps going to have lots of zircon in it, but there are other isotope systems such as potassium that decays to argon, which could be present in some of the materials and some of the minerals in the samples that we're going to retrieve from Bennu. And so we have a dating facility here run by a colleague of mine, which is absolutely geared up for that. It's very destructive. It involves sending the samples to a nuclear reactor to irradiate them, and then let them kind of cool down a little bit, and then they get blasted with a laser completely destructively to then release all of the argon gas, which we can then measure and then figure out how old that particle was. So that's one thing that we're hoping to do at Curtin.
Are you looking for things like CAIs? And no, that's got nothing to do with the American Spy Organization.
No, that's true. CAI stands for calcium aluminium inclusions, and they are some of the earliest solids to form in the solar system. There may even be tiny particles and fragments in these samples which predate our sun, exotic particles that have arrived and been embedded in the asteroid material from other solar systems and other solar processes. And these are called pre-solar grains, and they often stand out by being very, very different from the particles that are a part of our solar system. They have different isotopes and different geochemistry that make them shine out in our instruments very well, and we can study those and figure out what kind of sun, what kind of star that these came from, and what was going on in those environments. But we don't exactly know what we're going to get yet. We're hoping all of these components will be in the sample from Bennu, and we'll just have to wait and see.
That's Associate Professor Nick Timms from the Curtin University School of Earth and Planetary Sciences. And this is SpaceTime. Still to come, Iran's deadly nuclear missile program advances another step, and later in the Science Report, new details from the Australian Bureau of Statistics show that COVID-19 was the third leading cause of death in Australia last year. All that and more still to come on SpaceTime.
Hello, Saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Hello, I'm Ryan.
And I'm Catherine.
We're part of the BlendJet team.
And husband and wife. If you're one of the 5 million people who use a BlendJet portable blender, thank you.
A few years ago, I had a freak accident and almost died. Daily smoothies have helped me recover.
We created BlendJet to help people live healthier lives by making it easy to enjoy perfectly blended smoothies and protein shakes anytime, anywhere.
The BlendJet 2 portable blender is powerful, USB rechargeable, cleans itself, and comes in over 30 colors.
Get yours now on blendjet.com.
Iran says it's launched a new spy satellite into orbit. The 7-kilogram Nor-3 imaging CubeSat was launched aboard a Quasad rocket by Iran's Revolutionary Guards. Tehran says the satellite was placed into a 450-kilometre high orbit. The Quasad is a 3-stage rocket based on existing Iranian and North Korean medium-range ballistic missile technology. The launch vehicle is being developed and tested as the delivery system for the Islamic Republic's secret nuclear weapons program. That program recently received a $6 billion boost in funding after the Biden administration released frozen Iranian assets as part of a deal brokered by Sweden for the release of American hostages. The money had been frozen following repeated breaches of the 2015 Vienna Nuclear Non-Proliferation Treaty Accords agreed to by Tehran. A similar release of frozen funds was carried out in 2016 by the Obama administration when Biden was vice president. That netted Iran somewhere between $50 and $150 billion. The true total amount was never disclosed. This latest launch by Iran was another direct violation of the Vienna Accords, which are designed to prevent Tehran from developing nuclear weapons or the delivery systems to launch them, such as ballistic missiles. Last week, Iran suddenly banned a third of all United Nations nuclear weapons inspectors from assessing the Islamic Republic's suspected nuclear weapon sites. The International Atomic Energy Agency slammed the unprecedented move as profoundly regrettable, warning that it would harm the agency's abilities to monitor the Islamic Republic's nuclear programs. And just last month, the UN nuclear watchdog said Iran had made no progress on several outstanding nuclear issues, including reactivating surveillance devices that were disconnected by Iran last year. The International Atomic Energy Agency says Iran's total stockpile of enriched uranium is now more than 18 times above the limit set by the 2015 Vienna Accords. It's now estimated to be at least 3,796 kilograms, well above the 202 kilograms agreed to under the Vienna Accords. The UN nuclear watchdog says the Islamic Republic began using advanced centrifuges to enrich uranium in September 2019. And in February 2021, UN weapons inspectors found Iran had started producing uranium metal. Now, that's a material which is only used in nuclear weapons. It has no other use. Then in April 2021, both the German and Swedish intelligence agencies warned of growing efforts by Iran to obtain nuclear weapons technology. And a report by the International Atomic Energy Agency in May 2022 found traces of enriched uranium at 3 secret atomic weapons research facilities. Israeli intelligence says Iran now has enough weapons-grade uranium to produce at least 4 atomic bombs. That's enough to destroy New York, Washington, London and Paris. This is SpaceTime.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
And time now to take a brief look at some of the other stories making news in science this week with a science report. New figures released by the Australian Bureau of Statistics show that COVID-19 was the 3rd leading cause of death in Australia last year, the deadly virus accounting for more than 1 in 20 fatalities. This marks the first time an infectious disease has appeared in the top 5 leading causes of death since 1970, when influenza and pneumonia ranked 5th. The data shows COVID-19 was among the top 10 leading causes of death in all states and territories last year, ranging from the third leading cause in New South Wales, Victoria, South Australia and the Australian Capital Territory to the ninth leading cause in the Northern Territory. The virus was the sixth leading cause in Queensland, Western Australia and Tasmania. Official figures suggest some 7 million people have now been killed by the COVID-19 coronavirus since it was first detected near China's Wuhan Institute of Virology around September 2019. The World Health Organization estimates the true death toll is likely to be around 18 million, with over 770 million confirmed cases globally. Antarctic sea ice has reached a new record low winter growth, its lowest maximum extent since records began. The findings, based on satellite data from NASA and the National Snow and Ice Data Center, show that sea ice reached a maximum extent of 16.96 million square kilometres during a time when sea ice cover should have been growing at a much faster pace during the darkest and coldest months of the year. That's 1.03 million square kilometres below the previous record low reached back in 1986. The average maximum extent between 1981 and 2010 was 18.71 million square kilometres. Scientists are now working to try and better understand the cause of the meagre sea ice growth, which could include a combination of factors, including El Niño, wind pattern changes, and warming ocean temperatures. The fact that sea ice is melting at both poles reinforces warnings by scientists of a cycle called ice albedo feedback. You see, bright sea ice acts like a mirror, reflecting most of the sun's energy that shines upon it, sending it back into space. On the other hand, open ocean water is darker, so it ends up absorbing some 90% of the sun's energy that reaches it. With greater areas of ocean exposed to solar energy, more heat can be absorbed. This warms the oceans and further delays sea ice growth. The U.S. Department of Energy's Stanford Linear Accelerator Center has just achieved first light on the world's most powerful X-ray laser. The upgraded LINAC Coherent Light Source 2 ushers in a new era of science, providing up to 1 million X-ray flashes per second. That's 8,000 times more than its predecessor. Work on the $1.1 billion project began 13 years ago, involving thousands of scientists, engineers and technicians. The new X-ray free electron laser produces ultra-bright, ultra-short pulses of X-ray light that allow scientists to capture the behavior of molecules, atoms and electrons with unprecedented detail on the natural timescales on which chemistry, biology and material changes occur. It transforms the ability of scientists to explore atomic-scale ultra-fast phenomena that are key to understanding a broad range of applications. Scientists will now be able to examine the details of quantum materials with unprecedented resolution. This will drive new forms of computing and communications. It'll reveal unprecedented and fleeting chemical events to teach how to create new sustainable industries and clean energy technologies. It'll allow scientists to study how biological molecules carry out life's functions, to develop new types of pharmaceuticals, and to study the world on the fastest timescales, opening up entirely new fields of scientific investigation. In the process, opening up entirely new fields of scientific investigation. Australian skeptics have finally answered a question on everyone's mind: just who is the nation's best psychic? And the answer is all of them, according to their own descriptions. Following a recent flurry of self-promotion among the psychic community, Australian skeptics decided to look at a number of well-known psychics to see exactly how they rate. Tim Mendham from Australian Skeptics says they found that each and every one of the dozens of psychics they examined insisted that they were the best, and many said all the others were a bit chonky.
The skeptics, being skeptics, decided to look into the claims of various psychics. Now, recently we had someone on TV who was promoting themselves as Australia's best medium or Australia's best psychic. I forget what he was saying. Certainly simply the best. So we thought, what are the rest like? And so we did a bit of a survey. We looked around the websites and the media coverage of various psychics and things, and we were trying to find out who is Australia's best psychic. And of course, what we found out is they all are, or at least according to themselves. They all say that they're Australia's best psychic, Australia's best medium, Australia's most trusted trusted clairvoyant, Australia's leading astrologer and psychic, Australia's most trusted psychic medium, and on and on and on it goes. And basically, no one says, I'm the second best psychic in Australia, and certainly no one's going to say they're the worst, because the other continuing theme you find among psychics is virtually all the ones you talk to will say, yes, there's a lot of shonks out there, a lot of dodgy practitioners, a lot of fakes, but of course they're not one of them. In fact, one said they were the only one who wasn't a fake.
Of course. Just because you're the best psychic doesn't necessarily mean you're real.
That's very true. And of course, there's a lot of people who have the phone-in psychic lines. Now, we've actually put skeptics into those psychic phone-in lines. They went through the courses and got the endorsements, which from a couple of friends of theirs, and of course the courses didn't do anything. And they became psychics, online psychics, and they were given a script as to what to read out and to how to keep a person on the line as long as possible, because they're being charged by time. And they had no real way of clarifying the qualifications of a particular psychic. Therefore, the qualifications of a psychic is sort of a bit of an oxymoron.
I'm still shocked that you said there's a course.
Well, it's more a questionnaire. And of course, you answer the questionnaire, are you psychic? Yes. So basically, but of course, the other thing about the skeptics being spoil sports is we not just checked out if these psychics are the best, we also checked out how good they are, which is, sort of not just quantity but quality.
What are their predictions like?
What are their predictions like? And being the spoil sports that we are, we went back through 21 years of psychics' predictions, the sort of things you see that come up at the start of the year in January and things like that, where they say what's going to happen during the next 12 months. And this was in magazines, on TV, on radio, on their own website.
I bet you they all claimed the Queen was going to die.
Well, they claimed the Queen was going to die every year, apart from the actual year she died. Over that 20-year period, the poor Queen was going to pop off all the time, but they missed the actual year she did die.
Oopsie.
So, it was a bit silly because she was pretty old at the time. They think someone should have. But they missed a lot of other things too. They missed 9/11. They missed the death of Michael Jackson. But the predictions they did make, we went through and sort of divvy them up between vague, like I feel there'll be an earthquake somewhere, or there'll be a problem in the royal family. Yeah, thank you. That's the bleeding obvious one. Sort of there'll be an earthquake in California. So yeah, okay, there is every day, but never mind. And those that you can't check up, that Nicole Kidman will be sick for a few days, well, she's not going to tell people, basically. Something like that. And we narrowed it down to those that are actually accurate. And it was 11%.
Which is worse than just guessing yes or no.
Well, we also, because being the spoil sports we are, we also, skeptics, made our own predictions. Not guesses, but predictions, please. We're a lot more scientific than that. And we got a higher percentage right. We didn't do that good. I think it was about 17%. But at least we sort of got more that were right than the psychic. Even the Professional Psychics Association members got less than 11%. It was a funny old thing. I always think that if my mechanic or my car mechanic or my neurosurgeon is right 11% of the time, I'm going to choose a different one. But if they're all right only 11% of the time, I think there's something wrong with the industry. And that's what our story was on the psychic. They all say they're the best, and yet they always get it, more times than not, they get it wrong.
Is it a rich industry to be in?
It is. It is a rich industry. This latest fellow, who's been on a couple of TV shows and things, he charges $800 an hour.
Ooh.
Yeah, I know. And he's booked out until 2025, apparently, he says. But he does do group sessions as well, so maybe you can get in there at a bit cheaper rate. Someone estimated a couple of years ago the American psychic industry was worth about $2 billion a year, and that was an underestimate because most psychics are cash in hand, pass their palm with silver, that sort of thing. So they don't exactly know how much was being spent on the psychic industry. That's what they could uncover. And yet there were firms that were being, there was one firm that was being sued that had raised $2 billion over a few years of offering automated psychic readings and things. And in fact, because they've been found out, they gave back or cancelled the debt of $500 million worth. Now that's one firm. It's a huge industry, and for a lot of people, very lucrative. For some people, probably your average neighbourhood psychic with a crystal ball and things who charges you $20. And those sort of people with a shawl on, which are pretty ordinary sort of, they probably believe it half the time, believe what they're doing. Yeah, I don't think they're making a fortune. But the person charging $800 is either obviously Australia's best psychic, or is, I don't know,
yeah,
I hate to say on the record.
You don't want to say con man, okay?
No, but he is. He's one who walks around with a frequency scanner, right. One of those little sort of like radio-sized things, and going scanning back and forth across the frequencies, not stopping, but it then picks up. You pick up a little word here or there, or part of a word, because it doesn't stop on a station. It just keeps going back and forth. And he's using that in cemeteries to speak to the dead. He said, "Oh, I hear a word, Mark," or something like that, or
that could
Stuart.
Be a dog with a lisp.
It could be a dog with a speech impediment. Yeah, and that's an out and out obvious con. And he's been on 2 TV programs recently. He's been on 7:30 Report and A Current Affair, which is about.
It's always
extreme.
A worry when allegedly serious news programs start to interview them.
Well, the 7:30 Report was basically talking about supposed shonks and con men, but they gave him a good run. And The Current Affair was about other people complaining about someone impersonating him.
That's Tim Mendham from Australian Skeptics. that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more SpaceTime, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.